So this is my analog input circuit. When I press the button, the LED will stay on for a little bit. So this is my diagram for the analog input. So at default state, this will be high and the outputs will be low, and this NAND gate, the input will be low and the outputs will be high. Because both sides are high, the LED will be off. But when I press a button, this side will be low for a little bit, and the output of the NAND gate will be high. So it will charge up this capacitor and will slowly drain. And while that is draining, this NAND gate will input a high and output a low. So then the LED can go from the power to the NAND gate. This is my NAND gate oscillator circuit. When I press the button, the LED will oscillate for a little bit. So this is my circuit diagram for the NAND gate oscillator. So this part works the exact same way as the analog input. Because this input is a low, the NAND gate will output a high, a low, and a high to the LED, and the LED will be off. But when I flick the button for as long as the capacitor is discharging, this will be high because both of them are high. The NAND gate will output a low, high and a low. The output LED will be on. But the low signal will loop back here. So then this will be a low. So output a high, a low, and a high, and the LED will be off. And that is how the LED oscillates. This is my circuit for the decade counter. When I press the button, the bar graph will go from left to right for a few seconds, and the green LED will oscillate every 5 ticks. So this is how the decade counter works. So this part is the NGO. It is connected to the clock input of the decade counter, and so every time it oscillates, the decade counter will count by 1. And because it is wired accordingly to the bar graph, every time the counter counts by 1, the bar graph will move forward by 1. And the screen LED over here is connected to the carryout of the decade counter. So for 5 ticks, the green LED will be on, and for the next 5 ticks, the LED will be off. This is my circuit for the decimal counting binary counter. When I press the button, the LEDs will count from 0 to 15 in base 2. So how the decimal counting binary counter works is that the 4017 chip right now doesn't do anything besides making it oscillate 10 times slower, and the 4516 chip counts from 0 to 15 in base 2. And it is linked to the LEDs in a way that the LEDs will display the number that a 4516 chip is counting in base 2. So this is my final counting circuit. When I press the button, the 7-segment display will count from 0 to 9. And there's also a reset button to reset it to 0, and there's also a switch to make it count up or down. So this is my final counting circuit. All of these parts are from previous steps. And I've also added in a reset button and a up or down count switch. So what this part does is that it converts the signals from before, from binary into decimal, and then all of these output pins will output to the 7-segment display. So this is my final PCB in a case. So if I turn it on and click the button, it will start counting. And then I can also do this and then make it count downwards. This works exactly the same way as the breadboard circuit. It's just on a PCB.